Talk about a fun hack that we could use to check to see if two things can be in a smart container together. Smart container is a pretty cool thing that Lucid offers. It can actually be done via importing data or simply by using one of our shape libraries called smart containers. And it's a cool thing because I could actually use this to regroup how people are located together, basically. So if I wanted to, I could redraw this to sit people not by table number, but by department, for example. And I've done this two ways. One is by actually having recorded in the data set, which I can kind of toggle on and off in these fields over here, a list of people on certain cards that basically people cannot sit with. So including the list in advance of things that can't go together in the same container. The other way that I could do this is by writing a very specific callout rule. So let's look at the specific callout one first. I built a rule here that says, okay, specifically for if this is Janice, I know for a fact that if name is Janice, then Janice cannot sit with Tina. And I specifically want to highlight that. So I'm going to write a formula here that calls out and looks for Tina in the same container as Janice. So I've got a formula here that's doing something interesting. It's saying, go grab the contents of the container that this shape is in. So another way I could specify this, I didn't include it initially, but it's absolutely fine too, is I wrote this. So basically this rule is going to run on everything. We've already confirmed whether or not it has Janice. So you could imagine we're looking specifically at this card. So we're saying for this card, go find the container it's in, as in the smart container, and then go give me the contents of that container. So basically give me all the other cards. From there, what I want you to do is actually give me the names. So I'm looking for dot name, which is basically just going to give me a list of names. And then I'm going to say, okay, go ahead and filter down based on that. And within this filter, I'm going to say, take that list of names, run through it, and for each item, basically labeled X in that list, run this test. Does X contain Tina? Or rather specifically, I would want to care about X.name contain Tina. And if it does, then it should keep it in the returned list that comes out of this filter. At which point, we're just going to count it and look for, is it greater than 1? And what we're going to get, and I should probably fix that because actually, I think I don't want to specify that because the name is already being displayed. So what I'm going to get by running this formula is it's actually going to highlight for me, okay, Janice can't sit with so-and-so. And, I have this sort of custom hover text down here. It's using interpolated text, so double curly brackets allow me to put a formula inside the message. So it'll pull this dot name, which in this case we know is Janice. And I could also just say, Janice can't sit with, in this case I happen to know, Tina. That's my rule. That's what I created. It's a specific call out for blocking these two. Now, of course, that's great, but it's sometimes nice to be able to automate this or have it be a little more flexible. So that's why we have this other one. This one is actually relying on each card to be aware of the things that it can't be associated with. So in this case, we're actually just using one formula. We're saying something very similar, saying go get the contents of the container that this card is currently in and filter it down based on name, and then take that list of names and go see if in this list there's any of the names that are in this container with it are on that list. So it's actually saying, go check this particular card, in this case Gretchen Wieners, and see her list of can't sit with and see if any of the names in this container, Gretchen Wieners, Karen Smith, Regina George, are in that list. And if so, count the total results. And so what we're getting in this case for Gretchen, who's the only one who currently has that list, is this alert that Gretchen cannot sit with Regina George. We're adding an icon, and then we're using, that interpolated text that I referenced earlier. But this time we'll actually use it because I'm going to keep it flexible. I care about, this not name cannot sit with, and then we're actually going to go filter down and see who is triggering it. We're just not going to count which names popped up. We're actually going to hold those names and interpolate the text and put it in there so that the alert says Gretchen Wieners can't sit with Regina George. So that's a little bit more of an advanced rule. And you'll notice that, let's say I would move Katie over here, Regina George is suddenly going to get an alert because she cannot sit with Katie. So if I move these things around, moving Regina, suddenly my problems are fixed. I can move these other people around as well. And what we end up with, eventually by playing around is a pretty cool list here of people who can sit together. All our alerts are gone because we've made this work, and we no longer are seeing conditional formatting letting us know that this configuration doesn't work. Now, this is a very silly example from Mean Girls, but you could imagine that this could be used to check things like, actual employees, potentially if you're just trying to sort of mix up teams. Maybe you're trying to avoid putting senior engineers on the same teams together, for example, because you'd like for them to be distributed. We could also look at something like systems, if we're trying to group systems together, or if we're saying that someone can't be assigned tasks that are worth more than a certain amount. We could check for that kind of thing as well. Maybe someone's being assigned a task, and I only want people to be able to have one task that's worth 5 points, and everything else is fine. So you could use this in a number of different ways, but hopefully it's kind of a fun intro to conditional formatting and ways it can be used in Lucid.